After the basketball court and basketball are made, I can dribble the ball. But what I want to experience most is shooting. So, I have to make a basketball stand. As you can see, the simplest basketball stand consists of a base, columns, crossbars, backboard, basket and net. Among them, the basket and net are slightly more complicated, and the others can be made of regular geometric shapes. However, I am too lazy to design art materials. What should I do? Smart students must have thought of search engines. Yes, we can search on the internet. Here, I found some websites. You can enter the material you are looking for in the search box. For example, I entered a basketball hoop here. Then select the FBX format, set other conditions, and then click search to find a lot of resources. I would like to remind everyone that ordinary users of certain websites can only download a few resources for free every day. Therefore, it is recommended that you preview first and click to download after you find the satisfactory material. I will not download it. I imported the existing basketball hoop and basketball net material resources in my computer into the project. In the Resources folder, create a new folder. Rename it to Model to represent the model. Right-click and import from the folder. Import all. After the import is successful, you can see that this is the basket. This is the net. Create a new empty node. Rename it Goal Route. As the root node of the basketball stand. Adjust its position to one end of the basketball court. Create a new cube under the previous node. Adjust its scale value to use as the base of the basketball stand. Observe that it is more appropriate to set the scale value of the X and Z directions to 1 and the scale value of the Y direction to 0.1. Adjust its color to make it look like a cement block or steel. Create cylindrous spitum support. Adjust scale value to suitable size. Observation and testing show that the scale value as in and direction serceto 0.2 and the scale value in direction seto 1, which is more beautiful and reasonable. In order to give people the feeling of having an anti-collision sponge, we change its color to green. Duplicate the bottom pillar. Adjust its position. Set its scale. Set the scale in the X and Z directions to 0.1. Change the color to white or gray, so it looks like metal. Duplicate basketball stand beside to make a top beam. Adjust its scale value. Itis observe that Xandi scale value as Ariseto 0.1. The scale value can be adjusted to 0.5. Let's think about a question here. What is the appropriate height of the crossbar? Because the crossbar and the basket are roughly on the same horizontal plane. So, you can search the standard height of the basket through the search engine. The result we found is that in international competitions, the standard height of the basket is 3 meters. So, we can set the Y value of the top crossbar of the basketball stand to 3. Then use it as a standard to adjust the size and position of the rest of the parts. Switch to the top view and adjust the crossbar to the appropriate position. This will facilitate the subsequent splicing of the backboard. Press and hold the middle mouse button while moving the mouse to drag and adjust the view. Press and hold the right mouse button while moving the mouse to rotate. Scroll the mouse to zoom in or out. Next, we will assemble the backboard. Copy the beam and get a new node to use as the backboard. Similarly, through the search engine, we found that the standard size of the backboard is 1.80 meters long, 1.05 meters wide, and 0.03 meters thick. We adjust the size of the backboard based on this. Give the backboard a texture. Check Use Alpha Clip to make the backboard transparent and create a tempered glass backboard effect. You can also adjust the color of the backboard according to your preferences. Next, add the basketball hoop. Find the basketball hoop prefab we imported earlier. Drag it onto the goal root node to make it a child of it. Then, adjust its position. Adjust its rotation value to ensure that it is facing the correct direction. We can also get the size of the basket through the search engine. The search results show that the diameter of the standard basket is 45 centimeters, and the size of the standard basketball is 24.6 centimeters. However, the artists may not design according to this standard when modeling. So, if we set it completely according to this, we will find that it is a bit inconsistent. When running, the viewing effect from the player's perspective is not very ideal. So, we can put the basketball and the basket in roughly the same position for comparison. Switch to the top view. Scroll the mouse to adjust the scene window size. Select the basketball and first copy the transform properties of the basketball. Change the height of the basketball to 3. Then, drag the basketball to the top of the basket to compare the size. Make sure the basket is larger than the basketball so that the basketball can go into the basket normally. Of course, you can also adjust the size of the basketball according to the actual situation. After comparison, restore the basketball to the value set at the beginning. Finally, we set the zoom value of the basketball to 0.3 and the zoom value of the basket to 0.25. Run and find that the effect is ideal. Finally, put a net on the basket. Find the net prefab in the previously imported material. Drag it to the goal root node. Set its scale value to be consistent with the basket, that is, 0.25. Adjust its position so that the net is perfectly hung on the basket. Here, you will find a problem. If we rotate the net, its position will change greatly. The reason is that the coordinate origin of the net is not at the center of the net. When rotating, it not rotates around the center of the circle. If we want the net to remain roughly in the same position when rotating, we have to modify the coordinate origin of the model to the center of the net. You can use modeling software to modify it. But for us, the cost is high. Here we can create a new sphere object in the goal root node, that is, a sphere. Then change the y-coordinate of the sphere to 3. Switch to the 2D view to accurately adjust the sphere to the center of the basket. Adjust the sphere to be exactly the same size as the basket. Make the center of the sphere coincide with the center of the basket. Then drag the net node to this node as a child node of the sphere object. At this time, we can disable the mesh render component of the sphere object. Then adjust the rotation value of the sphere object. Select the sphere object just created. Press the E key and drag the arc to adjust the rotation value around the y-axis. You can also directly drag the Y value of the input box on the right to adjust it. Our purpose is to tell you how to deal with similar situations in the future. Friends who love details can try it yourself, and we will not make fine adjustments here. So far, the basketball stand is basically completed. Because a basketball court requires multiple basketball stands, we make the basketball stand into a prefab. Later, the basketball stand can be quickly generated through the prefab. Before making a prefab, it is recommended that you develop a good habit. Give each component of the prefab a meaningful name so that you can know what the node does when you see it later. Create a new prefabs folder in the project window to store prefabs. To avoid misoperation and data loss, we first select the goal root node and copy it as a backup. Then, change the z-coordinate of the goal root node to 0. Finally, drag the goal root node to the prefabs folder to get the prefab of the basketball stand. Of course, making a prefab of a basketball stand is time-consuming. You can also search for related models of basketball stands directly on the internet. Generally, you can use it directly in the game engine by downloading the FBX format. Now, we generate two basketball hoops using the basketball hoop prefab. Drag the prefab to the hierarchy window on the left. Repeat twice. Set the z-coordinate of one node to 10 and the z-coordinate of the other node to -10. One of the basketball hoops needs to be rotated 180 degrees around the y-axis. In this way, there are basketball hoops at both ends of the basketball court.